delivered today suggests nanotechnology for environmental remediation from Prof. Lai Chinwei, and advanced materials for energy and electronics from Prof. Goh Buntong. Yeah. Are highly relevant to our faculty direction toward sustainable engineering, green technology, and applied research with societal impact. We believe that this visit will not stop at knowledge exchange, but will grow into joint research collaboration, co-publication in high-impact journals, students and lecturer mobility programs, and establishment of international research networks. Yeah. To engage in meaningful discussion, share insights, and build academic connections. Because this forum is not only a platform for learning, but also a space for fostering future collaboration and co-creating impactful knowledge. Finally, I would like to acknowledge the dedication and support of all committees and contributors who made this program possible, especially the chair of the committee, Dr. Rahayu Purnama, under the guidance of our Vice Dean for Research, Innovation and Cooperation, Bapak Dr. Himawan Hadisutrisno. Our sincere appreciation also goes to partners, Prof. Dr. Lai Chinwei and Prof. Dr. Goh Buntong, as well as to all respected participants from the electrical engineering and civil engineering clusters. With that, let us begin this program by reciting Basmalah. Bismillahirrahmanirrahim. May this event bring meaningful knowledge, fruitful discussion, and lasting collaborations. Thank you. Wabillahi taufiq wal hidayah. Wassalamualaikum warahmatullahi wabarakatuh.
Thank you, Prof. Sylvie, for your warm and inspiring remarks. And the next agenda is symbolic submission of MOA between University Malaya and Universitas Negeri Jakarta Adel and all upward of respectfully invite the Dean of Faculty of Engineering to come forward to present a token of appreciation to our distinguished speaker. And the next agenda is respectfully invite the Dean of Faculty of Engineering to come forward to present a token of appreciation to our distinguished speaker. Ladies and gentlemen, before we proceed to the next agenda, we will now have a photo session. We would like to invite all distinguished guests, speakers, and representatives to kindly come forward to the stage for a group photo. Uh, Count on me. Okay, we will now have a photo session. Count on me. One, two, three. One, two, three. WNJ style. Count on me. One, two, three. Thank you. Please be seated.
Electronic. Oh, okay.
Ladies and gentlemen, we will now proceed to the main session, which is the public lecture. It is our great honor to have two distinguished speakers with us
Oh,
today
sure.
who will share their valuable knowledge and insights. Please welcome our speakers, Professor Insinyur Technologist Dr. Lai Chinwei and Professor Dr. Goh Buntong. And the moderator is the main session is Sarah Najla Hanifati MPD. Without further ado, I'd like to hand over the session to the moderator. The floor is yours.
Cek. Cek, cek. Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Selamat pagi, salam sejahtera bagi kita semua. Sebelum memulai our discussion today, Prof, izin saya ingin menyampaikan pantun dalam bahasa Malaysia. Correct me if I'm wrong ya, Prof ya. Pergi ke taman memetik melati, harum baunya si bunga raya. Selamat datang kami ucapkan sepenuh hati. Semoga majelis membawa ilmu dan manfaat kepada kita semua. Good morning for our distinguished guests, ladies and gentlemen, Ibu Dekan, Prof. Neneng Siti Silvia Ambarwati, Bapak Wakil Dekan, Pak Dr. Himawan, dan yang saya hormati Bapak Ibu Koordinator Program Studi, Bapak Ibu dosen, dan yang saya banggakan adalah mahasiswa. In this time, I will introduce myself first. My name is Sarah Najla, Magister of Education in Electrical Engineering. And I will be serving as the moderator for today, Prof. And it is an honor to be the moderator. Let us begin the keynote session. But first, saya mau bacakan kurikulum vitae dulu ya. Boleh dibantu untuk TV, Prof. Baik, he is our first speaker for this morning. Professor Engineering Technologies Dr. Lei Chin Wei from University Malaya, and he is termasuk top 2% scientist in the world, memiliki H-index 47, lebih dari publikasinya more than 457 ya, Prof ya.
Betul.
Dan citasinya lebih dari 9.800 di bidang nanoteknologi, energi, and material. Lalu ada pendanaan research grants-nya itu 7,5 juta ringgit Malaysia.
Thank you.
Oke, langsung saja tanpa perlu berlama-lama. This topic is exploiting nano titanium dioxide for advanced environmental remediation. Kepada Prof dipersilakan.
I will mention to you. Good morning, everyone. Selamat pagi. To thanks the and also would like to thanks to this program. For event. Dengar tak belakang? Okay, kan? So I will trample. So and I will try my best. What TiO2 can do. Anyone know what is meant by titanium dioxide from here? Because I know that you are not materials around, so maybe you are not understand what is titanium dioxide. Then titanium dioxide actually is TiO2. Okay, one of the advanced material we can use in product. The sunblock, sunscreen, white paint, art medicines use this titanium. So today I'm very happy to share some information regarding the exploiting light to environmental. My name is Lai. Right? I'm from Nanotechnology and Catalysis Center. So what we are going to designing various type of bahan nano, okay, and also pemankin, okay, in various application. So our center doing a lot of this kind of application. Our center also that's recognized as National Higher Institution Center of Excellence. We call HICOE, HICOE. Okay, so you also can what we call to join my LinkedIn if you have any invitation, information, workshop, seminar, conferences, or can get the information. Alright? So next. I think this one academic background, I think the moderator just not. Oh, okay. Yeah, just a brief one so you guys. I'm register myself as professional chartered engineering council, professional engineer, part under the BM, Board of Engineer Malaysia. In Indonesia, we also have the IR, right? IR also say like professional engineer. Also the professional technology, so technical consultant 12 company right now. Okay, also visiting expert professor, various universities. So mainly from Southeast Asia, China, Taiwan, yeah, and few more countries as well. Okay, I'm also editor for few journal right now. Editor for iScience, editor for Allion. Allion actually I terminated last year, right? So I also guest editor as well. I also publish few books, mainly for Taylor and Francis. Let's say you're interested, I also can share tips how going to publish in journal, how going to publish in book as well. Right? I'm also examiner for PhD thesis and so on. And postgraduate student, my team have a lot of postgraduate students right now. And I've completed about 16 PhD and 20 master students. I also received some award from friends and society and also here as well. Thank you. Next. Thank you, thank you, thank you, thank you. So you see Malaya, I'm Prof. Go, actually come from Sumber. Siapa pernah dengar you see Malaya tak? Siapa pernah visit Malaysia tak? Ada tak? Angkat tangan. Tak pernah. Tapi pernah dengar you see Malaya tak? It's one of the oldest UC in Malaysia. Okay. Okay, next. Maybe I will share some more information. So UN profile from here you can see that we have 21 faculties, 20 faculty. Okay. So we have about Pensyara, we have 2,000 plus Pensyara here, and we have about 100 professors. So we have more than 200 programs. Okay, so my center, research center, nanotechnology, part under the National Research Center. We have 5 National Research Center. So in 2024 we have published banyak juga 6,535 paper corpus. Okay, student we have 44,000 students. User Malaya. This is a record based on 2024, if I'm not mistaken. Okay, international student, we have more than 10,000 and come from more than 90 countries. Okay, next. The ranking, I think one of the most important criteria as ranked over the world, right? So we are ranking in 58 and also ranked in 12 in World University ranking based on the report of 2025. These are the annual performance for our. I think paper is very important for scientists and students as well. Publish and then what we are getting from our research. So paper is indicator to show that so in what level or what performance you have, right? So published paper is one of the important, very good practice, not only for lecturer but student also very important. Because when you go outside, go to further study, so the criteria used to or determine whether your level is based on the quality of your research output. Next. These are the 10 university class area. So we are focusing on 10 area. Okay, so below class area we are focusing right now. So my focusing area actually is in nanotechnology and quantum exploration. So inilah target ada utama bidang. Okay, next. Okay, di mana UC Malaya? So I think most of you all know that UC Malaya actually is located in capital of Malaysia, which is Kuala Lumpur. Okay, southwest of Kuala Lumpur. So from our campus in Daya, you can see a lot of the signature buildings. From here you can see the Petronas KLCC Twin Tower. Okay, the Twin Tower actually is about 10 kilometers from our campus, and we also can see the Menara KL Tower. And recently, we also have the world's second tallest, the skyscraper Merdeka 118 towers, very, very nearby when you see Malaya. It's about 5 kilometers, not that far. So we can see this kind of nature building from our campus. At the same time, you visited our campus, also can have a chances those famous. Okay, next. The facility, our center, we have a lot. So I just capture a few of it. I think technical what the faculty of engineering UNJ also have this kind of instrument is for analysis because we are of this kind of instrument. We have a spectroscopy hall, we have the FIR, Raman, microscopy, UV vis, and so on, PL, okay, to analyze and chemical properties. Of course, we will sharing this kind of instrument to the branch and throughout. Okay, next. And we also have the Raman, the X-ray. X-ray hole is XRF, XRD, XRD, and so on. So to provide analysis for the trace. Next. My slide is quite long. Maybe I'll try to talk. Cepat sikit lah, boleh ya? Okay. So this is our technical rector hall. Here is for the focusing on the performance and testing, especially for the petrochemical bio oil industry. So what we do here is actually we are biomass, oil, bio oil. So this one we are using this kind of instrument for the and this instrument also can be equipped with the. Okay, we are also utilize the conversion of CO2 to utilize this vector hall, this kind of analysis. Next. Siapa tahu tak apa itu nano? Sebab banyak tanya saya tak faham apa itu definisi. Siapa tahu tak apa nano itu? Angkat tangan, siapa tahu apa itu nano? Ada tak? Pernah tegak perkataan nano itu tak? Ya kan? So nano sebenarnya adalah suatu dimensi yang sangat-sangat kecil. Okay, it's much more smaller than the bacteria or viruses. So from the scale here, you can see that skala do nano scale dimension. So the viruses, you can see that. So the bacteria you can see is about 10 micron. You can see that the E. coli bacteria 10 micron. However, the viruses is down to about 60 to 140 nanometers. So this is a range of viruses. So for example, like few years back, the coronavirus, okay, virus corona do. So the size is about 60 to 100. Okay, the size of nanovirus. So that's why you can see that the virus actually can be airborne, but it's too light. So they will be airborne. Okay, that's why we can very fast transmission, very easy to transfer to. However, nanotechnology is much more smaller than the viruses. Okay, from here you can see that the nanotechnology I'm highlighted in the brown color. You can see that actually we are designing much smaller than. So far we are designing the first or quantum dots or any particle is smaller than 10 nanometer. So included the diameters, okay, included the sizes, thickness, and so on. So we are doing that kind of nanomaterial. Next. Click satu kali lagi. Click one more times. Okay, nanomaterials have unique properties. Everyone know that it's better than the bulk material. Okay, why we need to create? Mengapa kita kena menghasilkan ataupun design bahan-bahan nano itu? Sebab dia ada function, ada sangat unik. Okay, included the catalytic process. Okay, will improve a lot. Okay, electrical. I think you will come from electrical properties, right? So a lot of nano. Some of the device system they're also using the nano device. Okay, because of they can increase the electrical conductivity, magnetic properties, mechanical properties, directional, biological, and so on. A lot of these kind of advantages, the benefit. That's why we need to go through the nano size and also the next. So yeah, actually nanoparticle we can design a lot of the what we call the scripts and so on. I think most of the famous one will be particles to see this. Of course, the from particle we also can tune into different shape like needles, cubes, spheres, and so on. And we also do the surface modification, like functionalize, using some functionalized agent to improve the nano properties of material. Now next. Application of nanotechnology is too broad. I cannot cover one by one here. Maybe today I just cover a small group in the environmental remediation. How we are going to use the nanomaterial to control the environmental pollution. Okay, actually they involve a lot of the area like automotive, chemical, engineering, electronic industry, like your this area, right? So actually also nanotechnology. Tapi you tak perasan sebenarnya nanotechnology dalam sistem device. Okay, so in terms of the laser diode, glass fiber, optic curve, these are the item ataupun device yang menggunakan nanotechnology. So construction, Maxon also uses a lot of nanotechnology. Okay, next. Of course, the textile, fabric, a lot of the sport shoes. Okay, so they're also using some kind of the coating, the nanotechnology coating to improve some of the strength of the fabric or textile. Okay, energy. Right now, we have a lot of the renewable energy, green energy, like battery, solar panel, wave energy, so on. They are using technology as well. Okay, cosmetic product. I also involve quite a lot of the cosmetic product designing, especially the mask, nano white for the girls. They're also using a lot of this kind of. These are very famous. I have a big market. Let's say that for perempuan, wanita. So I think these are. That's why we need to what we call designing food and also the safe cosmetic product to everyone to use. Food and drinks, households, sport, outdoors, and so next. I always say to my students, leadership development opportunity. Okay, it's very important. Bridge between the academia, because we are academia, right? Scientists, researcher, and we need to link or cooperate with the industry. Okay, to fostering cooperation and to impact the world using our knowledge and experience, right? So I always say that the ideas, what idea we're going to solve? Like you have a project, we need to solve a problem statement. Okay, you must have a problem statement, and what idea you need to solve, what to incorporate industry. That's why I always say that we need to define it. Apakah cara-cara, apakah kaedah, apakah method to solve this kind of problems. Alright. So of course, when we have defined it, we need to have a test it. Test it means we need to analyze. Can utilize a lot of common task report, say that our method actually is work. Okay, it's very important. We can say that this material is very good, but we don't have any analysis, we don't have any data, we don't have any bukti to prove it. Okay, next we will design it. Okay, design it is for the next stage to commercialize. That's why we need to brand it. When you have a product, so we need proper design, like for scaling up. Only in the lab skill, but we are going to scaling up to industry skill, scaling up skill. Okay, so next we will be fund it or protect it by using the patent or IP or copyright, or using some IP to protect your design, because it's your own, so nobody can copy. So you own the copyright. Important, protect our what we call the idea. Okay, otherwise people will copy what we call the idea, and then I also can design another product to compete with you. And because you don't have any patents, you don't have IP to protect those ideas. Okay, it's very important to patent it or copyright it. And next, you can make to the next step to make it like scaling up. You can scaling up the machine, system, your device to next level. Next will be sell it. Next. I just started my presentation on time today. Actually, what idea behind I going to solve is that global warming. Global warming right now is a one. All over the world, we are facing the global warming issue. Compared to 10 years ago or 20 years ago, not that hot like currently. Temperature can be rise up to 40 degrees because of the global. Okay, so the global warming because of the emission, environmental impact to our sea level, weathers. Our journey is still a long way, to get rid of this. So my idea is that we are using size and nanotechnology to try to minimize or reduce the risk this of global warming. Okay, my idea is that using the TiO2. Today my topic is regarding the titanium dioxide. How this TiO2 can help a little bit to get rid of this kind of. Thanks. Next. Okay, so our center is nanotechnology center. So we did a lot of the metal oxide. Metal oxide means not only TiO2, have the silica, we have zinc oxide, we also have copper oxide. So depends what material you want to. So I say the idea is always important. need to have idea why you need. Okay, so my idea here is using the modified nanostructure in various environmental pollution application. So from here you can see that my group actually involved in macam-macam punya application. I think today we will cover a lot in, sorry, you back to previous slide. Okay, today we are focusing on more to 2, 3, 4. Okay, number 2 is more to the self-cleaning antibacterial antivirus coating. I think this coating is a long-lasting coating. So when we coat it onto any surface, so they can have what we call the properties of killing the bacteria or viruses automatically. So we no need to supply the cleaning agents, using some detergents, killing your bacterial virus. So this coating actually play a very important role during coronavirus times. I think a few years back in Malaysia, we coated in quite a lot of the hospital, clinic, labs, shopping mall, and so on. We apply this technology in various of what we call areas. And next will be the indoor air purification. And right now, I think we all also notice that indoor air pollution also very dangerous. Mungkin you all tak realize that actually indoor air pollution yang pencemaran udara sangat bukan di luar sahaja, tapi di dalam bilik itu sangat penting. Okay, that's why we have the issue or the idea we need to solve. Okay, and the fourth one will be the self-cleaning for the solar panel coating and also the cooling roof coating, solving some issue. Later I will share more details regarding this technology. Next. TiO2 not only in powder form. From here you can see that the powder, white powder, actually TiO2 normally the acid powder form, white color. Where we are using different technique, we can designing into various structure. Okay, because we are scientists, we can use the technology like the anodic oxidation, hydrothermal, sol-gel, CVD, PVD, and so on to designing this TiO2 into different shape, structure, and different sizes. Next. So in here, okay, from here you can see that actually the solution, the blue color and also the transparent color, that's the solution I'm designing for coating purpose. Okay, that's why we are using the electrostatic spraying gun here for the coating area. For example, like this room is about I think 200 square feet, so we can use gun to spray to all the surface, and this coating actually will be attached to the surface. Okay, we have two important purpose here. One is that we are going to have a long-term antibacterial and antivirus coating to protect not only for our, but we need to say that to protect the health. Okay, because last time the not only coronavirus, I think influenza. So you say you have influenza viruses or some, yeah. So very fast transmission. That's why we're using this kind of thing, stop the transmission risk, right? So another purpose is that we are going to use this coating to have indoor air purification with the VOC. VOC here is stand for the volatile organic compound. One of the very dangerous compound in the air. Anyone heard about the formaldehyde? Formaldehyde is one of the toxic gases. Okay, that's why we try to target it. We try to reduce this kind of the toxic gases. So this formaldehyde actually is released from the new houses. Rumah baru, ya ada bau baru kan? Bau rumah baru itu is one of the, like we say, that is toxic gases. Okay, we try to get rid of this kind of the gas. Next. So my first topic here, application here is regarding. Next slide, please. These are the sizes of the TiO2 nanoparticles. From here you can see that rubber size is number is about 6 to 8 nanometer. So very, very small. So we are designing this kind of the transparent coating layer, put it onto. So this solution can be coated onto any surface, included the wall, the ceramics, plastic, metals, on. So it will long lasting and it will create the long next. So the features and benefits, we always say that why we need to create this material. People will asking, people akan tanya, apakah kebaikan, apakah advantages of this kind of solution. So I think the first very important thing is that this must be safe, kena selamat digunakan kan. So we have a lot of the tested report, including to make sure that the safety criteria, so it's safe to everyone. Okay, not only kids, everyone or the public is safe to be used. So efficiency tests, self-sanitizing, long-lasting, remove the indoor VOC, the toxic gases, and also purify the air. And of course, the self-sanitizing here is for the 24 hours, it will automatically kill the bacteria or viruses. So these are the technology or the innovation we are using. Okay, next. So the tech design concept also very important, because when we applying the grant, when we want to write a paper, so we always think to the technology design concept, like use the chemical use, because using this technology, we are going to save the conventional chemical cleaning, okay? Bigger, like the one color, this color, different color one, okay? Pink color, red color, yellow color. Those it's quite dangerous if let's say you are using the reduce the water consumption, reduce the plastic waste, ecology footprint, and SDG. Right now, a lot of people they are try to link SDG, okay, and also the ESG as well, because of the eco-friendly approach by minimizing or zero usage of the harmful chemical to the environment, convenience and cost-effective, enhance indoor environmental and productivity. So these are the report. Because I have a lot of task report, maybe I just share one of the report. After the 30 days of the coating layer, for example, like on the table, okay, and then we are going to test after the days 30, it's still going to show the log 6 reduction. Log 6 reduction here means, what's mean by log 6 reduction? So from here you can see that the triangle shape too. From here you can see that we have log 1, log 2, log 3. Apa masukkan itu log reduction bacteria. So from here you can see that a lot of the advertisement, 99.99% is minimum log 4 reduction. Actually, it's fulfill WHO bacterial killing. So a lot of the product they need to is 99.99 is minimum log 4 reduction. Okay, means that for example, like you have 1 million of the bacteria. So log 4 means you still after the certain time, maybe 30 minutes or 30 minutes. Still got some bacteria still existing or still survive. Unless you hit until the log 7, means all the bacteria is killing. 99.99% means you still have about 1,000 bacteria surviving. That's the meaning of 99.99%. That's why this criteria we are using in log reduction for ours. We are using bacteria as well. So after the day 30, 30 hari. So from here we can see that after the contact time 16 and 24 hours, we able to hit the 99.99%. Okay. So these are we also tested the human corona last time. Quite serious. We also tested this coating also can kill the viruses, not only bacteria, able to kill the virus. Next. And we also using hygiene monitor system, because for example, like when we coated onto the floor, if possible we want to take a piece of sample from the building, cut, right? We cannot cut the piece of the cover or the pebble to test. So we are using our portable machine, the system we call the ATP space hygiene device, tested the level of the hygiene. So from here we can see that the level of below 500 is considered very clean. Okay, then moderator is 500 to 2,500 RLU, and also it's 30 is above the 2. Okay, next. So this device actually used a lot in our lab research, especially safety, lab safety, healthcare, because it's right. Just 10 seconds, then we can area yourself in, or is it 30? Because we use it for lab safety, and so that's why we always we will come out with a report, because this one 10 seconds we can use report and we can get the result from every day up to months also can be do this, because we are using device convenient. Next. Okay. AHU, everyone know the aircon. Aircon actually have a lot of the parks. I think this AHU is what we call the air handling unit, HAC, heating, ventilation, and air system in aircon. Aircon also very related. Sometimes maybe you are not aware. That's why we need to clean aircon every year, at least, because the field, so the 30 means a lot of bacteria inside your, but you cannot see it, because we cannot see the virus from our neck, right? Okay, so based on our experience, that's why we come up with a technology like that's on the coating level to coat it onto the AHU. Okay, so to enhance aircon and so improve the air quality, especially in our bedroom, living room, improve the air quality and deodorization. Sometimes the aircon when you open very oftenly, setiap hari buka aircon, you ada bau sangat sedap. Okay, tak ada bau tu. Okay, itulah besar kemungkinan akibatkan bau busuk. That's why we come up with this coating to killing the bacteria and come out with technology to solve odor and also self-cleaning antibacterial pliers and effectiveness. So I just give you an overall idea what technology we can apply this kind of technology. Okay. This I grabbed from some of my project. We are doing a lot of this kind of the small cube aircon, so we are coated with this of this TiO2 to sterilize bacterial, virus, and fungus, as well as decompose of toxic VOC. Okay, so this is a report I sent to China to do. So one is without treatment, another one is after treatment. What different you can see that actually before treatment you can see that before and after the bacteria is still a lot. Okay, after the aircon for 30 minutes and 60 minutes. Okay, so from here we can see that after the treatment of the coating, so the bacteria can be the HU system. All right, so after 30 minutes and 60 minutes, you can see that 99% the log4 reduction of bacteria can be achieved. Okay, that's why it's very important. We need to take care of our aircon. We call the cleanliness of our aircon. Okay, next. Okay, now I'm moving to next application, rumah baru. Siapa tahu tak rumah baru ada bau yang rumah baru kan? Kan tak? Dia ada kabinet, ada perabot, semua ada bau tu. Bau tu sebenarnya adalah formaldehyde for VOC. Right now, actually, a lot of countries they have a standard, right? China, Singapore, Europe country, they have their own. So sebelum you masuk ke rumah baru, so make sure that you meet. In Malaysia, we are working out on this as well. So means that you need to fulfill government standard before you can move into your new house. Because these new houses gases very toxic. Okay? It can cause a lot of illness and also some cancer. That's why you are not this. So from here you can see there's some article. The doctor warning unsuspecting item lurking in 70% of home may lead to cancer and dementia. These are the one of the disease famous. Pencemaran udara, okay, we call it. Alright, next. So what is formaldehyde? A lot of people mungkin tak perasan formaldehyde itu sangat ya. So mungkin saya boleh awareness. So formaldehyde actually is one of the hazard invisible killer in our. Okay, formaldehyde are organic chemical substance, especially it come out from the glue. For example, like adhesive, glue, preservative, home decoration material. So these are the material they will cause. So they are the bulk yang from the glue, preservative, and so on. This is why formaldehyde exceed the standard. So a lot of, especially if last time. Next. From here you can see that the long-term exposure is quite bahaya juga. From here you can see that. So can cause the chronic poisoning and illness. So these are formaldehyde actually listed by the WHO, the World Health Organization, international agency. Okay, it's one of the class 1. So dia akan mengakibatkan cancer. Okay, next. Tak boleh gerak. And the test report is also we sent to one of the lab to test it that after we coated inside our room. From here we can see that formaldehyde purification performance is up to 95%. So this is after how many 48 hours. So we tested again inside the room. Okay, So this kind of the air prevision much better as compared to without the coating. So we also have the taurine purification performance, and we also achieve a lot. So that will automatically be killing or to degrade those bacteria and also the VOC. Next. And we're also using the device. We have a lot of the projects. In our campus, we also have the campus or some of the project. So we are doing this as well for the safety and also the air purification. So from here you can see that we are using the nano photocatalytic decomposition method. So these are the method we are using to killing the bacteria and also to degrade the toxic gases. So nano photocatalytic decomposition method. These are the method we killing the bacteria and degrade the gases. Okay, so indoor formaldehyde can be volatile in large quantity in air in short period. So these are the technology and beauty of this technology. So dia hanya perlukan guna untuk cahaya, even though sunlight, so it can activate this kind of thing. Okay, next. Sorry, back to previous slide. We can use a lot of the portable device, because how we going to measure the indoor air quality? Actually, right now in Shopee, Lazada, in a lot of the shopping platform, you can buy this kind of the indoor air quality tester to test that whether your indoor quality is either very clean or either is very. They have a standard, just like the bacteria. We also can use this kind of meter to know that okay, keadaan bilik kita okay, selamat. So it's not expensive. I think 200 in Malaysia, so it's cheap, so that you can know that whether our indoor quality, especially for those pregnant women, kids, or you have old people, so you better that we need to take care of this kind of what we call the indoor air control. Okay, next. Okay, my next application is also using the same technology as well. We are using the TiO2 coating, but we apply onto solar panel. I'm not sure Indonesia involve a lot of solar panel. Other planet solar panel. In Malaysia, we have a lot of solar farm because right now the government they push to the green energy. One because of petrol harga naik kan. So we have a lot of the strategies. We not only in industry farm, but we also apply in our housing. Dalam rumah kita pun apply juga. So we are using the solar panel heater and so on. These are the technology. However, this kind of technology, actually we have solved two issues. Okay, next. Here is the cooperation with industry. As I mentioned just now, industry role, so that we know what they need, that we can supply or we can provide our knowledge, experience, help them to solve the issue, so the problems. Okay, next. So from here we have two images. One is sangat kotor, one is sangat bersih. I think you are from EE. I think you all know better. Which one have a better performance? Can clean solar panel or dirty solar panel? Answer is clean, right? Because clean solar panel actually involve a lot of the solar absorption. When you have dirty, and you have a coated layer, the very dirty layer, so you can block the sun absorption. When you have a panel using a SiO2 silicon, so that will drop 30% just one month. So regular cleaning is essential for such installation. So lambat-lambat performance you akan jatuh 30% hingga 50%. So that's why we come up with coating technology to solve our issue. Next. This is one of our project in our campus. We are using the coating layer. From here you can see that we have two target. Kita ada dua matlamat, dua objective. Okay. One is we are using to further enhance the solar panel output. So after the coating, you can generate more electricity. Okay, increase the annual solar power generation, leading to a better ROI. Because industry they always look for a better ROI, return of investment. Okay, the second one will repel the water and prevent build up. This is our target. So setiap research, we must have the objective. Okay, what you want to solve, what idea you have, right? So we are using the 5 layer here. We have coated the 5 layer of TiO2 onto this kind of solar panel, and then we can increase 3%, about 3. Now we have a lot of the apps. I think right now we don't need to measure the solar panel by laptop and everything. We can using the apps, and then we can monitor time to times. That's why right now we're also running a few projects using apps. We can see all the performance. Okay, so these are the 5 layer. You can see that. So where the white coating uniformly cover the entire area, resulting in high absorption and significantly enhance the white efficiency. So these are the AFF surface topology. We also can see, because when we coating, so they have more active surface area to absorb more light. Okay, so that they can trigger better electricity. Next. So these are the data collection. From here you can see that if let's say that you are from EE, you are already clear kilowatt per hour per day. So red color is after coated the TiO2 nanoparticles. So the middle one is clean. We clean it, the old solar panel. You can see that it's slightly increasing. But the inverter number 4, the last one, the last bar, actually is very dirty. So we can see that there has significant drop in electrical output. Okay, next. And we also tested the Hall effect measurement for the mobility. I'm not going too details in this one. This is analyzing the what we call the performance of solar panels. Next. And we're also using the UVs, okay, for the material analyzing. So this result from here, you can see that because solar panel, we need to make sure that they have a lot of the transmission. Need to at least 80. So from here, we cannot put too much of the layer. Otherwise, you can see that you drop the blue color will drop. Okay, so we maximum to put until 5 layer of TiO2 nano coating. Next. The thickness. So we're doing the coating. A lot of people asking how many thickness. So we're controlling below 100 nanometer. So 5 layer above 7.55. Signal using profilometer. Next. Okay, the last application I want to share here is that using the cooling roof. It's our new technology in our research center. We are using the coating, but we are reducing the room temperature. Okay, that's why this idea come from. Next. Okay, so for example, right now we sangat panas kan sekarang. Walaupun kita buka aircon, tapi pun kita berasa sangat panas. So that's are the residence and commercial building account for 4% of energy. Aircon still feeling the hot. And the HVAC, the aircon system, contribute to 40% of energy of use in the building. So that's why we need this kind of energy to generate the cooling effect. Okay, last year I think May 2025 is recorded the second hot our world. Okay, it's raised by 1.33. It's a lot actually. Okay, so next is our issue we want to solve. Okay, so our idea is that we're trying to come up with the roof cooling thing. So cooling roof coating is a reflective surface treatment dalam bumbung marketer. Okay, it will reflect the sunlight and also the heat. Okay, to reduce the heat absorption by deflecting the sunlight and lowering the temperature. Right, so this is our idea. Same time, we also can extend the lifespan for the roof by protecting it from the UV damage and thermal stress, so on. Next. So we have 4 ultimate aim here. One is energy saving, waterproofing, roof restoration, reduce CO2, and next. Global warming, as I mentioned just now, we are trying warming because it's getting hotter and hotter every day. Okay, active cooling means we're using aircon, have the aircon system in our room, but we are using another system as well, passive cooling. Repel or reflect the heat or UV back to the environment. Next. So from here we have few strategies. Designing strategy for reactive cooling material system. We have 2 important criteria we need to consider. One is low solar absorption and also high mid-infrared emission. I'm not going through details on one criteria, very details. These are the basic criteria we need to consider. So every research, every project, we need to identify which material or which system you want to use. Because of pro and cons, you need to consider that. So that's why it's very important. We need to carefully select the material. All right, next. So we have objective, high performance, scalable radiation cooling materials, and also the material possess high refractivity and high emissivity, and also the most important thing is it can scalable preparation method. Very important because we want to coat the whole building. We need to use a lot of this kind of materials. Okay, next. Okay, from the result, next I will show the result. These are the result we are going to test it. I think you are from EE, you all know that. This daytime passive radiative cooling performance. PVA is one our polymer coating doped with the TiO2 particles. Just now the coating layer with structure. From here you can see that we have seen some temperature difference. Okay, so the best difference is about 6 degrees Celsius difference. So before and after the coated, you can see the difference. Okay, next. So these are the technology behind the SiO2, thermal effect, radiation trap, radiation cooling. So these are the mechanism. Okay, next. These are the best result we have so far. The porous structure boosts the radiative by scattering sunlight and enhancing refraction from the TiO2 layer, giving above the 6% drop. So after the coating, so we can feel the temperature difference, right? So next. Okay, I think this is my almost the last slide. Collaborator. I always thank to my team, not only in my university, but also have a lot of collaborator. Not only in local, in Malaysia, but I think in Indonesia, China, India, or some is come from the industry as well. We pay a lot of importance. Because I always believe that research is a teamwork. We cannot work alone. If alone, you cannot work very far. That's why we always build and we grow as a team, so that we use the expertise from our team and then we try to solving a problem. Okay, for example, I am from materials and also engineering, so maybe I of these ideas, and maybe you are come from electrical, some materials, maybe we can collaborate together, get solution, provide some solution to solve the next. SDG, I think in Indonesia important juga kan. SDG, the Sustainable Development Goals. We have I think I have 16 or 18 goals here. So we also try to link to this SDG. Okay, so now CAT is according to support SDG directive at improving the planet and quality of human life around the world by 2030. Next. My last message is that our devotion of duty for a better nation. Okay, so this is a very important milestone for all of us, especially for young generation, the country hopes. Hopefully that in future you all can have using ideas, your experience to help not only your country but all over the world the real issue. Okay, because the science is continuous. We cannot stop at one stages, but we need to continue. Also need continuous study. Don't stop at one stages, but continuous learning, professional learning as well. This is very important. So because this embark our journey in attending this focus pillar under the SDG, and we are committed to bring the positive impact. Positive impact means so for a better living. I think that's all from my lectures news today. Hopefully that you all can enjoy. Not very deep, because I am not involving a lot of the technical analysis, but just the overall idea how we're going to convert our research to commercialize or use in our real application. I think we have one last slide. It's about my cooperator. Okay, so I visited a lot of countries and use it. So a lot of cooperator. I'm very happy to share today's experience sharing that we can have more projects. Okay, not going to step that we stop here, but in ongoing can have a lot of projects, events, sharing knowledge. Okay. Last but not least, I would like to thank you, Angel, again. High invitation. High invitation. Inviting me to here to sharing with you. So with that, thank you very much for your attention.
applause for Prof. Lai. Thank you very much. Take a drink first, Prof. Minum dulu.
Very long. I think about 45 lama. I think we can open to discussion. That's why do you have any question? You nak apa soalan you boleh tanya.
Terima kasih Prof. Lai. Izin sesi tanya jawabnya setelah Prof. Goh ya. Thank you Prof. Lai. Sangat inspiring and ternyata nanoteknologi ini sangat memiliki peran penting yang kita sebenarnya kurang aware tentang nanoteknologi. Contohnya seperti toxic gases, it's one kind of nano. Yeah, but I'm not really aware for nano. Oh, ternyata toxic gases itu termasuk nano ya, Prof ya. Kalau di Indonesia bilangnya debu, Prof. Debu. New house. Ya, new house ada debu.
Sometimes we cannot depend on one technology, like debu is one of the a lot, right? That's why we need to come out with a lot of the purification machine that combo of a lot like UV irradiation to killing the bacteria, and we are using the coating filter. Okay, so filter also very important for debu. Okay, so that's why sometimes we need to combo a lot of technology in one system. We cannot hanya satu teknologi, satu bahan dalam sistem kita. Okay, thank you.
Saya akan mengambil 2 poin penting, 2 important point from Prof. Lai. The first one is published paper is one important. It's not only for educator but also the students. And the second, we need to patent and copyright to protect our idea. Okay, that's the second point.
Yeah, I think very important. So now patent sebenarnya is very important to protect our innovation sometimes. Okay, so especially for lecturers and students, you have idea, so you try to copyright it or patent it. Kalau tidak, you punya teknologi akan diambil orang lain. So dia jadi orang lain punya. So sometimes the industry they can buy your copyright or your patent. So pihak industri dia akan beli kalau dia minat your patent. So that's why you need to use this kind of technology to gain a lot of knowledge, experience. You boleh jual you punya patent kepada orang lain sebab you ada patent. Okay, so it's very important. Paper, of course, is very everyone also very important for us. Okay, especially student, lecturers, we need to publish paper. Okay, it's our KPI as well. So mengapa kita kena menghasilkan Scopus Index paper? Sebab we buat kajian kan, so you kena ada banyak result analysis. That's why one of the way you want to share to everyone is using paper. Okay, kalau tidak your thesis, your analysis you keep inside the library, so no one will know your contribution. For example, like you are EE, right? You have your project, so no people will know what your contribution in this area. So if one paper, for example, like the Scopus, so people not only from Malaysia or in Indonesia, but it's all over the world. Seluruh dunia akan baca you punya kajian. So it's very important. So people will start to cite your paper, acknowledge your paper because you contribute in this area. So for me, not only student, but I think lecturer also will do the same. So because we need to publish and we need to sharing our research output. Okay.
Tepuk tangan lagi untuk Prof. Lai. Terima kasih Prof. Lai atas pemaparan yang sangat insightful. Selanjutnya kita memasuki keynote kedua, yaitu Profesor Dr. Goh Buntong. Boleh ditampilkan kurikulum vitae. sih. Standar-standar.
Okay, so terima kasih. So yeah. So first, I would like to thanks UNJ for inviting me to share my research projects and research topics that I putting on the slide here. So yeah, so I'm actually from Low Dimensional Material Research Center. So I currently working in this Institute for Advanced Studies, very close to Profli's research centers. Yeah, we are actually from University Malaya. Then, of course, I also affiliated with Department of Physics, Faculty of Science, University Malaya. Yeah, here is the title or the topics today. Before I go into the detail, probably just thank you, Prof. Lai, for very inspired talk. So yeah, for me, I think my topic is much more on technical parts and research and also fundamentals of the materials. Before I go into again details, or probably I think it's related because Prof. Lai mentioned about carbon nanotubes. So maybe you have anyone hear about nanowire? So probably it's kind of the material is a one of the category in the nanomaterial. So nanomaterial divided to 2D, the two-dimensional material like graphene oxide, or molybdenum dichalcogenide, what we call it MOS2. So the fundamental property is the very thin atomic layer. So like graphene is one single atoms. Then MOS2 is molybdenum and two sulfur top and bottoms. So it forms one single layer. So and it is not normally can find environmentally here. It's not stable. So we grow on through the experiments, then we produce it, then we make it stable. So you can't find it in the natural. Okay, so graphene. So then we look into the next material is called nanowire. So nanowire is, as you know, it is like carbon nanotube. Nanowire is a wire. So what is the special of nanowire? Because it's the length over the diameter is more than 1,000 aspect ratio. That means it is very tiny and very long and very small. Okay, so I will going to talk about the application of this nanowire in the energy. For example, hydrogen productions, supercapacitors, and some electronic properties like electrical conductivity. That is what you familiar. So more on magnetics applications. So before I started, I would like to request if you have a question or you need any further explanation, please raise out your hand. So I'm happy to answer your question, especially among the students here. Okay. Right. So a little bit of introductions because since I prepared, so this is University Malaya, so DTC, the Dewan Tunku Chancellor, quite old buildings, I think. We have a new building here. This is a new Chancellery building. So the management office all in the new Chancellor building. So we have a very nice lake. This is the IAS, Institute for Advanced Studies. So it's located on this block. We have 4 blocks. So it's block A, B, C, and D. This is D. A nanocare is A and I think C. Okay. So if you look at the top view, so this is a whole campus. It's not really big, but yeah. So it's quite green. So here is the lake. This is actually quite small, but it's quite nice lake. So the university is quite green. It's located in Kuala Lumpur, somewhere I think 5 to 10 minutes to city of Kuala Lumpur. So next, if you coming from the Jakarta, is to just I think it's 1 hour 40 minutes to reach to the KLIA airports. So here is the member of the Low Dimension Material Research Center. We have 10 members. Prof. Haliza, then Professor Venkatesh, and there's myself, and Dr. Suhaimi, Dr. Azuriani, and so on and so forth. So this is the physics department buildings. So we have 3 blocks. I think this is A, then B is behind, then C is further behind. So of course some another small buildings where we is another branch of the low dimension material research center. Here IES, we offer quite a number of the postgraduate programs. For example, full research program, Master of Philosophy, PhD of PhD, Doctor of Philosophy. We have quite a number of the coursework programs, Master of Renewable Energy, Master of Agriculture Biosecurity, Master of Advanced Studies. Of course, we also have few programs coming soon. Then we also have a mixed mode Master of Applied Science Nanotechnology. This is directly under NanoCAD. Okay, here is the outline of my talk today. So I will give you a very brief introduction on the nano material, nano wire, what we call it nano one-dimensional material. Then again, some of the properties of the nanowire and the application. After that, I will move on to my focus is silicon-based nanowire. So it's quite number of the formula here. So silicon nanowire, nickel 3, silicon 2. Nickel 2 silicon because nickel silicide is quite complex material. It can form various type of phases. Then I can make it into the cold shell. So probably interesting properties. That means cold shell is a nanowire coated with another layer here. It's called cold shell. What we in the semiconductor we call it heterostructures. Electrical heterostructures. Then single nanowire, single phase, nickel 3, silicon 2 for supercapacitors. Then I will move on to my recent work on CVD, chemical vapor depositions, grow manganese silicide, which is interesting properties for magnetic, ferromagnetic, even room temperature ferromagnetics. Then manganese 4, silicon 7 for hydrogen production and also ferromagnetics. Lastly, I will show you some of the optimization and also the morphology control of these manganese 4, silicon 7 nanowires. Okay, so I think Professor have give very clear introductions about how exactly the nano size of the nanomaterial. So if you go into very, very small, like 10 power of -9 meter, that means you take your hair, you just take one piece of hair, you cut into the 100 pieces, then it will be in the nano size, probably it's 10 nanometers. So you can see some of the example here, like this one is actually published is quite long time ago. So it's 1964 by this Warno. So it's about 300, it's about 50 nanometers. Okay, so the unique property here is the aspect ratio larger than 1000. That means you take the length divided by the diameter is more than 1000. Of course, because this high aspect ratio, if you give you very large surface area. So this is very important. Like for example, you do it for the sensor, you produce solar cell, you absorb more light, which conventional structure you cannot do that. Then you can have a very flexible nanowires, flexible surface, and high surface functionality. So you can functionalize to different type of application. For example, gas sensor, different gas, ammonia gas, nitrous oxide, carbon oxide, carbon monoxide as well. So nanowire density usually is larger than 10 power of 9 per centimeter square. That means centimeters area, you can find more than power of 10. That means it's 1 billion nanowire on 1 cm times 1 cm. Okay? So of course it's very good in the crystallinity, very low lattice mismatch, and you allow the electron to flow very fast. So you also can easy to control the morphology and the band gap, which is a very important parameter in semiconductors materials. Okay, the lastly is form the cold shell structure to improve the intrinsic properties. For example, if you're naturally the wire is not good to certain environments, for example, high voltage, or maybe high temperature, so you coat another layer. For example, you coat silicon carbide, which is high tension material, then you can get to do the two application in one device. Okay, here is some of the example here. So 1991, Professor Summer Ijima from Japan, he's discovered these carbon nanotubes. So let's see the picture here. So yeah, so this is a single wall carbon nanotube. Then this is a multi-wall carbon nanotube. So it is very interesting for many kind of application, medical especially. So then Charles Rieber, 2001, he found the silicon nanowires horizontally, very tiny, and Professor Song, 2007, which all these aspect ratio larger than 1,000. Because here is some of the application here. So we use it for this, what we call it, energy harvesting. So we put the mechanical force on the nanowire. So you can see here is a zinc oxide nanowire, these pictures. So we press it, power. So it's actually it's because of the piezoelectric properties. So you press, you generate power. So this power you can use it for smart device, which is a portable device. For example, you put it on under your shoe. Yeah, you just walk around. Then this power generator can maybe power your smartphone or smartwatch. So you can save the electric. Yeah. So it can be used for thermoelectric. That means temperature change, it can generate the voltage. Biosensor as well, because it is small, like just now Prof. Lai mentioned about the bacteria, very small. Nanomaterial is much more smaller than bacteria. So you can detect various kind of the bacteria by using nanosensors. Okay, you can detect COVID, or you can detect different kind of the virus on the airborne. So yeah, of course this is a very conventional type solar cell. So silicon nanowire can produce 22% of quantum efficiency with absorption of 85% of sunlight. Of course, you can use it for lithium-ion battery, which is electric vehicle nowadays. It's very popular now. Okay, so the next slide I will just very briefly go through how you can grow the nanowire. It's not like very simple. You can just put it there, nanowire will grow. It's not like plant. So nanowire, you need engineering. You need some understandings on the nucleation and physics behind the growth mechanisms. So you can see here, I will highlight the importance of the silicide growth here, which are growing a lot of kind of different beautiful morphology of the nanowire in my laboratory. So we divided into the three categories. So VLS, what we call it, vapor, liquid, and solid. So it's very simple. So you have to go into the liquid and you form the solid nanowire. The next one was much more easy, vapor, solid, solid. Then vapor, you straight away form the silicide wire. Of course, in this case, you need a catalyst. So this is a metal catalyst in the transition metal. Then you need to understand the melting point. It's very simple. You already have a melting point in your periodic table. So as long as you're able to heat it out to that particular melting point, and you have a control of the size, you're able to grow wire easily in the nanoscale. So here is some of the example. You can see we grow silicon nanowire in the last 20 years ago, 10 years ago. So single crystal nanowire. Then we use the Indian catalyst. Why? Because Indian melting point is very, very small. It's about 165 degrees Celsius. So you just need to heat it out 200 degrees. You will melt the Indian and form the nanoparticles. Then you just need to supply the silicon in the gas forms. It will grow silicon nanowire easily. Okay. So you can make the flower. You can see here, this is what we call branch nanowire, silicon and zinc oxide cold shell hierarchical branch. So you can have a silicon wire, you grow the zinc oxide branch, then you can have a two property together in a single wire. Of course, you can form a cold shell structures. This is cold shell structures. Then we managed to grow on the 6-inch silicon wafer. So this is the silicon wafer. You can see my hand and the camera. Once you coated with nanowire, is totally zero reflections. That means the nanowire absorb the sunlight because the large surface area. So you can compare with different substrate here, silicon substrate. You have a catalyst, then you have a silicon nanowire, then you can see it's totally dark. That means the sunlight has been absorbed by the nanowires. And we conduct the optical measurements. So you can see here, this is a reflections at the visible region. That means cahaya boleh nampak 400 nanometer to 700 nanometer. The reflection is close to zero. Right. So if you enlarge it under the electron microscope, you can see nanowire is quite uniform. And we managed to have a very good night meter control. And also we can actually improve the current density of the light absorptions and also gas sensing properties. Yeah, there's a paper published in the journal, so I think if you are interested, you can refer to the paper for the gas sensing applications. Let's look at the next one is the what we call it hot wire chemical vapor depositions. So this is a system available in the laboratory. We have 4 units, so to produce different kind of the nanowire and also 2D material as well. So it gives you a very low temperature process, like below 500 degrees Celsius. It can produce large area. So as I show you, 6-inch wafer is no problem. Then we can control the crystallinity and also some of the transition method, favorable and tunability. So very simple. I think I have a picture here. Yeah, you basically just need to flow in the gas. Then these high temperature filaments will break the gas and it go down to the substrate. So the gas will decompose to the single elements. Then it will break down to they will deposit on the substrate. Of course, the substrate you need a catalyst. So then you're able to grow at different kind of the substrate, like silicon wafer, on glass and on nickel. So the morphology is the same. Then you can actually control the filament temperature. This filament temperature, you can see the morphology from the small nanowire to nanorod. Again, cold shell structure, and lastly, silicon carbide and nickel silicide. Yeah, you can see here, this is the phase analysis to show you can have a pure single phase of nickel silicide, then silicon nanowire, then nickel silicide again, then silicon carbide start to appear at high filament temperatures. Of course, this mechanism is due to the decomposition rate. So at the low temperature, you decompose the silicons, and high temperature, you decompose the methane in this here. This is what we call it gas phase reactions. I think I do not need to go into the very details. Yeah, here you can see from the microstructure studies under the transmission electron microscope. So I put it 2 samples here. So this is the low temperature, this is high temperature. So you have these cold shell structures. Then you can have a silicon carbide as a shell at a higher temperature because high temperature allowed to decompose the methane gas at. Yeah. So the nanowire diameter is quite small, around 10 nanometers. The shell nanowire can go out to I think can go out to more than 20 nanometers and maybe 50 nanometers as well. And you can change the phase from crystalline phase to amorphous phase, depend on your applications. Right, the other one is you can pay attention on this 2 nanoparticle form here. So once you come to the high temperature, they have accumulations of the nickel silicide at the core nanowire. Then due to the surface tension, it actually form the what we call out diffusion, and eventually they grow the branch. I can show you later on and the branch applications. Of course, we study the catalyst size and also higher. Then we look into this what we call it nucleation limited silicide reaction to model the range of the temperatures and also the diameters. Right, then we calculate the activation energy. What it means is as long as you apply the similar activation energy, you are basically able to grow wire easily. Okay, so then the next one is the optimizations of the nickel silicide and silicon carbide cold shell. So you can see here from different pressure, we managed to grow high density nanowire and vertical align. So it's vertically aligned. So this is very good for solar cell and also some of the energy applications. Right, we conduct the capacitor measurements, what we call it specific capacitor measurements. So you can see here we managed to achieve quite remarkable enhancement in the specific capacitance here. So it's about near to 250 millifarad per centimeter square. So surface area 2 cm times 1 centimeters. I think it's quite technical, so I will just briefly go through. So if you are interested, we can have more discussion later on. We also control the shell diameter. You can see the data is here. So the 2.0 SCCM of the methane flow rate, we get very tiny of the core wires and also the shell thickness. But interestingly, the specific capacitance, we reach until 500 millifarad per centimeter square. So this is quite good achievement in this supercapacitor measurements. Of course, it's related to their silicon dioxide formation and also silicon carbide control in the phase here. Right, okay, so if you remember that I show you the nanoparticles due to the out diffusion, the filament temperature to 2150 degrees Celsius, we actually force the nanoparticle to out diffusion from the shell structures. So this is the picture. Then it's actually happened to everywhere, but just a typical picture we selected here. Then you can see from the SEN, so the nanoparticle actually grow the branch. It's what we call ultra sharp tips nanoneedles. So there's many branch everywhere on the pictures. So we measure the crystal structure as well. So it's a single crystal, and the diameter of the tip is about 5 nanometers. The shell thickness is nearly 50 nanometers, and the core diameter is about 20 nanometers. So then we measure the field emissions. So this is used for light emitting applications. So under the high power, actually we're able to produce very high tension of field emitter with the enhancement factor of 2.4 thousands. So current density is quite remarkable. And of course the turn on voltage is 10 watt per micrometer. So compared to the conventional type material, is still large. So yeah, we are working on that. In the future, probably we're able to reduce it, because you don't expect to use high voltage to increase the current density. Okay, so next one is the what we call it nickel 3 silicon 2. So we use it for these ferromagnetic measurements, and you can see from here, this is a 4K and this is a 300K. So 300K is room temperature. So we measure the ferromagnetic with very small amounts of magnetic field from 20 to minus 20 kilo OE. So it's able to give you a very high intensity of the magnetizations. So see for many like magnetic storage, for example hard disk, or maybe floppy drives, or maybe USB based on magnetics principles. So yeah, so this one able to apply into the very type of the magnetic applications in the room temperatures. So why this is high? Because it's a single crystals. Then of course we change the morphology and with the different temperatures. So even you can see for the next structure is the we put it on the nickel foam. The aspect ratio is close to 1000 with the diameter of 13 nanometers, and again the single crystals. Then we put into the 2 electrode system on the super capacitors. So we measure the CV and we measure the charge discharge. We're able to achieve 600 farad per grams, 6 farad per gram, yeah. So this is quite good, say, compared to the previous work have been published elsewhere. Then we also, this actually can create a new avenue for the nanowire base for supercapacitors in between the supercapacitor values and also battery power, specific power, and also specific energy density here. Right. Yeah, the next one is the stability is quite good. It can go up to 3,000 cycles. So we managed to maintain the stability about 80%. Okay, so this is the last part of the nanowire nickel silicide nanowire research. Of course, it's taking a long way to do that. This costs a lot of money. So we use the focus ion beam. We put into the interdigital electrode. Then we use the platinum electrode to coat it. Then we measure the single wire of the nickel silicide and also the cold shell. So we conduct the current voltage measurement. We measure the conductivity of this nickel 3 silicon 2. So the conductivity is about 9.5 times 10 power of 5. So it's actually highly metallic. It's close to metals, which is 1 times 10 power of 6 per ohm per centimeters. Right, okay, the next part is we move on to this, what we call it manganese silicide and manganese 4 silicon 7s. Again, this is quite simple compared to the hot wire CVD and also the nickel silicide synthesize. So you can just put it into the alumina box, you put in the manganese powders, then you stack the silicon wire on top. So you can see it's quite uniform here, its density is quite good, power attack 9. Then you're able to get very uniform on the manganese silicide nanowire. So we study the top substrate and the bottom substrate, and the crystallinity structure is different. So you can see from the data here, top substrate we managed to get manganese silicon 50%, manganese 4 silicon 7 is 50%. But interestingly, you can look at the bottom substrate is about manganese 4 silicon 7 is 81%. And manganese 4 silicon 7 is a semiconductor material. So you can use it for many semiconductor applications like solar cell, energy storage, hydrogen productions, and so on and so forth. Right, we studied the nucleations. We found that this is again the catalyst growth. This is a cell catalyzed. So the seed here is manganese 4 silicon 7. We check the crystal structures. Yeah, manganese 4 silicon 7. We even check the tips and also the branch. So I will go to the next. We conduct the what we call it density functional theory calculations. We check the ferroelectric measurement again. So here is the bottom substrate. This is contributed mainly by the manganese silicide and manganese 4. And you can see here the room temperatures ferromagnetic have been remains, but the intensity dropped. So this intensity could be due to the oxidation of the nanowire, and this one can be improved in the later words. So we check again the charge distributions. So the spin charge density localized at the surface. So that is followed by the nanowire mechanism, growth mechanisms. Right. So of course we like to do some engineering. So my student conduct the experiment with different pressure. So from 0.12 millibar to 0.52 millibar, then 0.12 millibar as well, 1.2 millibar. And you can see here again, we use a similar principles, single nanowire, then we start to introduce the pressure, then it create the out diffusion again on this manganese silicide nanowire, which is similar with the nickel silicide nanowire. And higher pressure, you can start to see there's a saw structure here, zigzag structures. And this zigzag structure actually is all by this manganese 4 silicon 7s. We conduct the crystal structure studies, then the oxidations, X-ray photoelectron chemical spectroscopy studies. We check the oxidation effect. Yeah. Then again, we conduct the ferromagnetic measurement again. We just briefly go through the pressure. You can see 1.2 millibar here. The intensity for the room temperature and the 4K is similar. So we're able to maintain the ferromagnetic properties at a higher temperature, especially at the room temperatures. So the stability is quite is quite good. Yeah. So we are also going on with this specific capacitor measurements. I think the work is still ongoing, so I think I do not need to. But you can see on the hydrogen generation, this is what we call HER, hydrogen evolution reactions. So this line is the platinum, standard platinums. So the D is a nanowire grow at the 0.12 millibar. So because of the good conductivity, they're able to produce a higher current density, which is close to the platinums. So that means it indicates that you can able to generate hydrogen at large scales and high yields in the very low voltage potential. It's about 0.5 Okay, so optimization have been going on. So we change the filament temperature because of these ferromagnetic properties. So we start to observe at these two parameters at 830 with the source structures here, and 850 we increase the pressure again 0.52. Then this is the source structures. So we are working on that. So I think we hopefully to get a very nice result in the coming soon. Probably for those interested, we can do a collaboration on this work. Of course, we further study on this oxide on the nanowire surface. So nanowire grow on 0.12 millibar and 830 degree and 0.52 millibar and 850 degrees. Demonstrated lower oxygen contaminations and expected to have a higher manganese 4 silicon 7 percentage. We reported nearly 75%. And we're expecting this nanowire could most likely produce high room temperature ferromagnetic magnetization. We are still going on with the analysis of this DFT calculation and also crystallinity structures and also compositions. Okay, so here is brief conclusions. The hot wire CVD demonstrated a great capability to grow real type of the 1D silicon bases with the different morphology. So you're able to control the substrate temperature, pressure, and filament temperatures. Then these two types of the nanowire can serve as one-dimensional electrode for electrochemical supercapacitance. Then after that is the ultra-sharp tips can produce very high tension field emitters. Then, as you remember, there's this interesting nickel 3 silicon 2 nanowire show a very high potential electrical conductivity, as I reported, is close to 1.10 power 6 per ohm per centimeters. So this high electrical conductivity can give you a very good application in the transistor, LED, solar cell, and etc. So manganese silicide and manganese silicide 1.7, which is actually in the family of the manganese 4 silicon 7 nanowire, can produce by this what we call it confined reactions. So we able to control it systematically with different compositions, morphology, and also the crystallinity as well. So, and this nanowire perform very good in hydrogen productions through the electrical catalytic processes due to the conductivity as well. Then this nanowire exhibited excellent physical and electrical and magnetic and electrochemical properties such as high density, high metallics, and extremely high surface area and ferromagnetics. So further study is still going on, so I welcome any interested potential collaborators to join us. Right. So here is some acknowledgement, especially to my students. Quite number of students working on different areas of research in wide nanowires, 2D energy, supercapacitance. Yeah. Okay, and also some funding agency. I think, yeah, this is the last pictures. Again, show you the very green campus and also very nice lake. I think it's along the year there's many activities like in the kayaking activity around the lakes. Yeah. Okay, I think. Thank you very much. Yeah.
Big applause to Professor Go. Thank you for your presentation, and we will going to question and answer. Yang ingin bertanya silakan menyebutkan nama dan asal program studi Bapak Ibu. Ada yang ingin bertanya atau dari mahasiswa silakan. Ya, silakan.
Bismillahirrahmanirrahim. Good morning, Prof. Lai Chinwei and Prof. Goh Buntong. I'm sorry about my English and my pronunciation before. Thank you for very insightful presentation about nanotechnology. Very useful. Let me introduce myself. My name is Rehan Abilito. My major is electrical engineering for Faculty of Engineering, University of Jakarta. My question is a simple question. What are the challenge to applying this technology? I mean nanotechnology in this world, in this condition world now. Thank you. What the challenge? Tantangannya apa? To applying the technology, nanotechnology in this conditions of world now. Thank you.
Thank you very much for your question. I think it's very clear about your question. Nanotechnology in real world application, right? You mentioned. Oh, betul tak?
Betul.
Sebenarnya sangat luas nanotechnology. As I mentioned in previous slide, you still remember that my previous slide I mentioned that application in my earlier slide. I actually all of the areas I think they also involve the nanotechnology. Mungkin kita tak perasan. So for example like the handphone, inside also a lot of the nanotechnology or nano device we call it. But tapi kita tak perasan. Tapi sebenarnya kita ada banyak device or coating or circuit, so they are using the nanotechnology. So actually my answer is nanotechnology is everywhere. So in our room also a lot of nanotechnology. Okay? So no matter your devices, your laptops, your even to some microphone, sensor, so car, okay? So they're also using a lot of like coating I mentioned just now. So can be in our building as well. Okay, maybe they're using the nanoparticles, okay, inside our rooms like the paint, chart, okay, yang semua tu mungkin dia ada unsur-unsur, ada bahan-bahan nano. Tapi kita tak perasan sebenarnya. Sebenarnya my answer is everywhere the nanotechnology, especially in perubatan, medical, they're also using a lot of the nano drug to targeted to kill the cancer cell. They are using the, we also can design that. So they are using some nanoparticles, okay, with some vaccines, so to killing the targeted cell as well. So my answer is everywhere nanotechnology. Thank you.
Yeah, maybe I can share my some of the thoughts here. So heard about like processors, microprocessors. Nowadays they go to like people talking about like 2 nanometers. Yeah, 2 nanometers. So that is very small. Probably they have a few thousands of millions of the transistor in this 2 nanometer because the technology. So nowadays people like for example company like TSMC, maybe Samsung's or all these big semiconductor companies, they are working toward very small chip which can do a lot of things, right? For example, our smartphones. So our smartphone considers a lot of nano devices because actually it's quite small. So it can perform a lot of things. For example, application, it can conduct different application. You can run many application apps in the same time. For example, you can have a light. Light is from the LED. Probably it's a visible light because you just need the light. So and the color is controlled by the device, which is using nanotechnology device to control the colors from the blue to green, orange, yellow, and red colors. So this is all controlled by the nanotechnology devices. Okay, so like mentioned about just now, because I have a research with, there's a medical scientist in University Malaya. They get my nanowires to read the drug, okay, to drag the drug to deliver into the certain area locations, a very localized area. Then after that, because nanowire, they have a very good in terms of heat absorptions. Of course, you need to functionalize it. Then you use the heat to to dissolve the drug to let fuel into the area that you want to cure. For example, some cancer areas, yeah, or maybe certain place which are affected by the virus, yeah. Okay, anything else? Like the nano generators, like you press, you get the power. That is very common in a lot of places. What else? Yeah, I saw there's another interesting like titanium dioxide. Actually, I went to a place in in Japan, one of the hotel, if you see the mirror, you can just put the water there. The mirror actually will not, the water will not stick on the mirror. The water will just flow out. Then it keep the mirror very clean. This is because the hydrophobics of the nanoparticle that coating on the mirror. So it won't let the water to stick on the mirror. Then in this case, the cleaner no need to clean the mirror every time, right? Yeah. So that is a nanoparticles. Of course, that hydrophobic can use in many applications like antivirus, antibacterials. Yeah. Okay.
Thank you, Prof. Go. Oke, ada lagi penanya? Oke, silakan.
Okay. Good morning, Professor. So my name is Fikri, and I'm from Electrical Engineering Education. So thank you for the insightful presentation. Considering the growing environmental challenge and the need for sustainable energy, I would like to ask, how can nanotechnology, especially in material like nanowires, contribute to improving the efficiency and reliability of renewable energy system within smart grid implementation in developing countries like Indonesia? Thank you.
Smart grids.
Yes, smart grid.
Could you explain more? I'm not familiar with smart
okay.
grid, but maybe you can tell more detail about smart grid.
Maybe like how can nanotechnologies, especially in materials like silicon-based nanowire, contribute to improving the efficiency of renewable energy system with smart grid implementation?
Okay. Yeah, I don't think I read any articles about they use a nanowire, because in order to produce a nanowire, you at the nowadays I think it's not easy to produce in the large scales. Like you can go out to like 5 centimeter times 5 centimeter, or maybe 6 inch of wafer. But talking about smart grid, it's a system, and the network is quite big. Probably the carbon nanotube they can consider. I heard people use carbon nanotube in building a lot of like cables, electrical cables, because it's high conductivity. But I don't have any info about how the carbon nanotube apply into the smart grid. But that is possible, because carbon nanotube is flexible, and it can be produced by large amounts, high yield. So you can get the carbon nanotube in 1 kilogram in the online markets, e-market. But I think silicon is difficult. As you see, the slide I presented is mainly a single crystal. About single crystal, you relate something with the very fragile, where you can't come to the nanowire, easy to break. It's not as flexible as a carbon base. Yeah. So of course, if that can be resolved if you have a large scale of productions, then probably they need to think about how to make a cold shell or functionalize it in order to make it flexible. Then it can be either straight or maybe like cold shell, just ring around the cables, and you can do a lot in terms of the electrical transfer and telecommunications. That may be possible, but I don't have any info about. I didn't read any info about using silicon nanowires, but carbon-based nanomaterial, nanotube or nanowire, may possible.
Maybe I add some points regarding you. Actually, nanomaterial, as I mentioned, we have a lot of choices. Because material selection, we are not going to select one. Actually, all material also potential. Just depends on, is it cost? Is it scalable? Right? For example, like we have a lot of the biomass, like we have the carbon, is one of the resources. For example, like we have a lot of the parties paddy, right? It's paddy. We have a lot of paddy field, palm oil, coconut. So all we can convert to activated carbon. It's one of the way we can get the nanoparticles. The easier way is we converted to all activated carbon. Activated carbon also can be applied in a lot of applications. Okay, like gas absorption, wastewater treatment. That's I mentioned just now, right? So it depends what material you want to use. Always remember that the ideas is very important. So okay, so and then we try to explore what are the solution and what are the what we call the idea, the novel idea. You can solve the issue. Okay, for smart city, actually in Malaysia we have a lot of projects that have they started or launched this kind of smart city. They have a lot of the green index, betul tak? Dia ada index dia, for example, like renewable energy, water supply, air pollution, and everything. So actually, this is a very good concept because right now we are going to have a very great green environment, right, to support the SDG, ESG. So I believe that not only in Indonesia or in Malaysia, but all over the world, they are very support this kind of the concept, green city or smart city. Okay, they are using the renewable energy like solar panel. Okay, they are using the air circulation system to cooling down the environment temperature, and also they are using some renewable what we call recycle, not using plastic. They are using the recyclable material. Okay, so they have a lot of this kind of index. So as a scientist or as a researcher, we always think about this kind of the index or smart city or green city. So this is our what we call motivation, all right? Motivation to solve this kind of issue. Of course, the nanomaterial, as you mentioned just now, silicon, nanowire, also mentioned by Prof. Go, not easy to scaling up. Maybe we can use the alternative material to substitute or replace your materials, all right? Because as a what we call entrepreneur or industry partner, they always look for ROI. If let's say that the cost is very high, so your city or your building, the cost will be very high. So you susah nak jual nanti. Sebab sekarang we have a lot of the competition with the China products, yeah, murah. So even though your material is very good, very efficiency, but the cost is super high. One will buy your building, your product. That's why we always will think out of the box. At the same time, we can maintain the green index or smart city or green city. At the same time, we also can what we call save our earth and using the recyclable materials or good materials. All right. That's why I give you example like activated carbon is one of the good choices. You can try to explore more what we call opportunity and also the platform. I think Indonesia and Malaysia a lot of this kind of biomass. All right. Thank you very much.
Okay, thank you, Professor. That's very insightful. Thank you so much.
Okay, thank you, Prof. Go and Prof. Lay. Mungkin satu lagi ya, Bu. Oh ya, silakan Pak Imam. One.
Okay, thank you very much. Maybe I will ask about the material from the Mr. Prof. Lay. That you have choose the one material, titanium oxide, dioxide, right? In the last presentation.
Oh, sorry, which one?
Titanium dioxide.
Titanium dioxide, yes, TiO2.
Yeah, why you choose this material? And do you have another material that you have to
as I mentioned
in
just
other
now,
project?
our group also study a lot of
Yeah,
material. But today
yeah.
topic we try to like the
Okay,
TiO2.
maybe you can do that. About the first about the material and the second
why we
about
select this material? Because
yeah.
okay, first reason is my personal reason because I study PhD using TiO2. So I have a lot of the knowledge, experience. I can how to control the particle size. So I can very familiar. For example, like be familiar with carbon, then you can familiar with carbon. So I studied this material more than I can say that 20 years. Since my final year project, during your degree, the final year project, I started TiO2. So I'm very familiar the property play around. So I can designing. So of course our group not only limited to TiO2, we also explore a lot of the carbon, like graphene, quantum dot, and so. But TiO2 for me, first is very light activated, and the second thing is safe, as I mentioned just now. The material we apply to the what we call the commercialized we need to save. Kalau tak selamat, so tak boleh nak commercialize, and we have a lot of the problem as well. Save and also the cost effective. Because nano, one thing is the beauty of the nano TiO2 is that the small quantity, okay, of the TiO2 can have a very good performance rather than we using a big foil or the content. So we can control to less than 0.5% of TiO2 inside the solution, but the performance we get actually is very good. So we controlling the cost. Faham tak? Dalam solutions mungkin 1 liter air tu hanya 0.5, maybe less than 1% of TiO2 inside, but at the same time they can give us a lot of good properties in terms of antibacterials, antivirus, self cleaning, and so on. So at the same time TiO2 not easy to produce until less than 5 nanometer. So we have the novelty, the pattern. That's why we have a lot of patent in TiO2. We control inside the size. Bukan semua orang senang nak produce. Itulah idea, and we try to protect it using the patented or copyright, and then we commercialize. Kalau tidak, you have a one good product, tapi semua orang boleh buat. So semua orang boleh buat, so semua orang boleh hasil you punya product. So no point you go to this way, right? So for me, TiO2 have few properties like cost effective, one thing, and another one is easy control, because you need to control the sizes, the phase, okay, like the shape control based on the application. Okay, at the same time we have a lot of the collaborator, they also working in TiO2, so like we can match with the industry partner, they are working in this area as well, so we can explore a lot of the application. And right now we also penetrate to different market. Okay, not only in Malaysia, but I think in quite a lot of countries we also started to sharing, or we try to explore this kind of market. Thank you very much.
Morgan, and that you have the explain about the coating process, right? With the electrostatic before.
Oh, sorry, what costing?
Coating process. Coating.
Oh, coating process.
Coating process. So you can more detail the coating process.
Okay, coating process.
And how is the drying process? It's need the more maybe the heater or something.
Because now we are not in lab scale, so we need to think about the real environment, the challenges and difficulties. So we are using the fast drying. Of course, inside the solution, we need to include some adhesive, some polymer, or some what we call the fast drying agent like alcohol. So when we dry, so it can stick together to the wall. So they can form a semi-permanent bonding. So at the same time, dia tak akan keluar atau peeling off. So can stand to after dia dry dalam 30 minit, I think about 30 minit under the room condition. Okay, so dia akan dry and dia akan form bonding. Okay. So you don't need to use the oven heater or no. So it's automatically will dry. We have tested the hardness actually will increase up to 6H if I'm mistaken. Something like the car coating, we coated it onto any surface like tables, wall. So we are using a simple method, just spray it. The method we are spraying is using electrostatic spraying, not conventional gun spraying. We're using the electrostatic spraying. So it's more efficiency, and we can control the thickness below 100 nanometer. That's why it can form a very good bonding with any surface. If you say too thick, okay, not, dia akan banyak habuk. That's why we need to control the thickness below 100 nanometer, as I showed in Prop and just now. Okay, we're using the electrostatic spraying. So that's why it's very straightforward. We coat it, and then they will apply onto. Dia tak akan hilang, dia tak akan peeling off, so it will stable. Okay.
Okay. The last is, if our laboratory will be expand to the nanomaterial, what's the tools that we have to prepare? Like maybe like the camera, like the SAM tools, and maybe you can describe to us, because we have the
boleh.
Because we have
boleh. I think kita boleh bincang bunyi dalam section lain apa kita boleh buat. I think we have few strategies because we also started from a small lab. Now we are going to national center. Boleh. Oke, thank you, thank you. Terima kasih.
Terima kasih Prof dan Pak Imam. Masih ada sesi tanya jawab, silakan selanjutnya. Silakan perkenalkan diri, nama dan asal program studi.
Okay, good morning, Professor. Thank you for your insightful explanation. My name is Rosalindra Putri Masloman. I'm from Electronic Engineering. In nanotechnology, especially in silicon-based nanomaterial, the performance of materials is highly dependent on their size, structure, and uniformity at the nanoscale. I would like to ask, what are the main challenges in controlling the size and uniformity of nanomaterials during the fabrication process, and how do these challenges affect their performance in practical application? Thank you.
Okay, so thank you for your questions. Yeah, this is quite interesting. So probably some of the part is quite fast, but probably you can remember 2 points. First is the nanomaterials, and especially nanowires or 2D material. They are not nanoparticle. They are not actually exist on the natural room temperature and room environment, atmospheric pressure. So that is the first thing. So you can't get a nano material everywhere, right? So the second thing is I did mention about this is a control environments. This is called, how to say, nucleation. If you want to get the nanowire to nucleate to grow, you need to have a high amount of the precursor in the confined environments. So that means, for example, you heat it out the temperature, then you have a precursor, you have a gas in the control environment. So you just let the gas go into the control environments. Then you need to, the most important, you need to achieve the called supersaturations. So once you achieve the supersaturation, it will grow the nanowire in the very short time. It cannot grow very long time. Usually it's not going to happen very short time, like 10 minutes or 5 minutes or even maybe few minutes. Okay? So that is two things, two factors. So the next one is if you're able to get the supersaturation, that means you're able to grow the nanowire. Then the next thing you need to do is control the pressure, you control the temperature, and also the last one is you control the amount, the precursor. So the precursor can be in the powder or can be in the liquid, even can be in the what we call it, powder is solid, liquid is a liquid. I mean, it's in the solution base. Then you can control the gas. So there's the three things. Real kind of mouse is depend on what kind of applications. So because this slide I also only prepare on the silicon base. I grow metal oxide like indium oxide nanowire. I grow iron oxides, and I even grow different kind of the zinc oxide, and not like titanium dioxide but zinc oxide. Then it depends on the application, like your wide bandgap or your high metallic. Okay. I grow like silver nanowire, pure silver nanowire, and also some nickel oxide or nickel inorganic nanowires for like COVID application actually. So it depends. So you need to achieve very good supersaturation condition. Then after that you use it to control the size, the morphology, and you control the phase. So then that it depends on what kind of the application you want. Phase is mean like you can have an oxide, you can have a nitride, you can have even carbide for semiconductor. If it's purely the metallic, you do not need to control gold nanowire, silver nanowire, or copper nanowire. Yeah. Then okay, the next part is the crystallinity. If you want to have a very good crystallize, you require a very good temperature. That means high temperatures. If you below 200, I don't think you're able to. Usually, you don't grow very good crystallinity of the nanowire. Okay, so crystalline maybe that means it's a very high order or atomic arrangements. Then that usually use it in the electrical applications. You want the electron to flow very fast, so you need a very good atomic arrangements, very high crystallinity. Okay. Yeah. Okay.
Okay.
Thanks. Any questions? Yeah, please.
Okay, Prof. Actually, I have a question
yeah,
from mine. I was very interesting with your presentation, Prof. First, maybe for Prof. Lai. Professors, could you please explain why clothes stored in a cupboard for a long time start to smell? Smell is not good, and then maybe is
You
there
mean in
any
new houses
bacteria?
or new cabinet?
Yeah,
Oh.
that's right, Prof. That's from my question, and then Prof. For Prof. Go. How are nanowires being integrated into fashion materials, and what is the benefit do they offer in terms of the fabric performance? Thank you, Prof.
Okay. I think this question is everyone also want to know why we install a new furniture, or especially for example like a new home, right? Rumah baru. So do we have this kind of the smelling issue? Okay, especially for new furniture. So if let's say that you are in let's say a closed environment, if let's say that you are not open your windows, so the smelling can be stay there for a few years because you are in closed environment. So normally what we advise, for example, like our student, our client, our customer, so we advise them to open the windows. You say, so we need to use the air circulation to kalau tidak you memang sana. So you are quite dangerous. If let's say you are pregnant, you have a small kid, so they are very easy to get sick because these are very toxic. You can check from internet and everywhere. They have a lot of article, and the WHO, the World Health Organization, have confirmed that this kind of the new home smelling is very toxic. Okay, so everyone is aware of this. Don't say that this is already good smelling and you can smell for every day. Especially when you sleep, actually you are consuming a lot of these kind of gases, especially in your lung. They can hurt your lungs, and it have a very long-term impact actually. So my advice is that why you still have this kind of smelling, because of you are in, I think as suspected, you are in very close environment, and you don't get a proper solution. For example, you can put some charcoal, you can put some activated carbon, can temporarily solve your issue. Okay, because a lot of the new house buyer, they want to go move into the new house immediately. After ada rumah baru kan, after install everything, they want to stay. So that's why a lot of them that come back to me, they say that how we can get rid of this kind of smelling issue in a very short duration, maybe within 1 week or few days. So the smelling and the level of the formaldehyde can drop to a very low, what we call the level. Yeah, betul. Boleh. Dengan Dr. Rayu. Okay. Real pepper. I think this issue is recently quite hot because of awareness. A lot of public, the awareness is starting high because of the corona, the cases of corona. So a lot of people that are aware of this kind of the health awareness. So they want to get rid of for protect their family, to protect their kids, and also for health. So I think this issue maybe can look attention into this. All right, thanks.
Okay, I think I can add something on that. Probably also with this paint coating, like to protect the furniture, but eventually it creates other gas emission that may not be good for human health, and maybe for respiration system. Yeah. So the other thing is, previously I also get to intention on this because they also have this some furniture may have create the humidity issue. So because we actually are quite narrow in the range of the humidity, So that's why we need to put the like air purifier in our house or in the rooms. Yeah, our humidity level range is not really wrong, so I think that can be another thing to our human health issue. Okay, so probably your question I think is difficult for me to answer because yeah, but probably some of the things that carbon nanotube that people put into the fabrics and to strengthen, and the other one is to keep your, some of the helix or spokes. They have two things is they put the nanowire into the clothes to that is called I think anti so again to something with the sweat. So yes, there's one thing. The other thing is for sweat. You don't want the sweat to stay on the clothes. That can be another problem also to our health, our skin. Yeah, for some people sensitive with the skin, sensitive skin, they are not good with. They are not comfortable with the sweat. The sweat can be create by bacteria issue again. So that's one thing. The other thing I think is for the temperature control. So they can keep the temperature very, very good, and probably it's more narrow in the control of the temperatures and putting the nanowire. Of course, you may need to apply some electric something. Yeah. Yeah. Thank you.
And that's why I need your guidance as our paper, Prof. Thank you, Prof. Next, Prof. From our Vice Dean 3.
Okay,
Silakan, Pak.
for Prof. Goh, maybe I will, I need for provide for me an overview for the nanowire usage, especially for safety. For safety, yes. Perhaps for clothing or etc. or other, maybe Prof. Goh can give me overview this issue.
I think safety can be something we can discuss here because I have this one because I working with one colleague in the chemistry. So she used this for biosensor. So and also we working on the things like portable Ramans that we call surface enhanced resonance spectroscopy, SERS. ERS. So because nanowires can actually easy to, this is hybridized with the nanoparticles. What we want actually, we want to coat the nanoparticles, but the intensity is not so significant. Then we try to think about one solution is we deposited the nanoparticle on the nanowire, because this surface you can coat probably 1,000 nanoparticle. But if you have this surface, then you can triple out the nanoparticle amount. Then we scan under the Ramans, we get the surface enhanced resonance. So we increase, I think, even go out to, 1,000 times of the intensities in the Raman signal count in particular range of the vibrations, referring to the silicon vibration peak. So yeah, it's 520 per centimeters at 520. Yeah, that is a TO, is a transient vibration modes. So in that particular, they give very high intensity enhancements. So if this is the things, we can use it to detect for safety in the airport, like for example, security test. So we use the portable Raman to scan on the signal with the certain elements. They will show you the Raman will show you very high signal. Then this kind of elements, we will detect easily through the Raman's detections. Of course, that will be a more selected range because some of the dangerous items, so we need to calibrate with the Raman signal based on the silicon wire deposited with silver nanoparticle. So people have been reported. We also have discussed this before previously, but I didn't try. But it's you're using the biosensor to do that. Yeah, that is. Yeah.
Thank you, Prof. Our last question maybe from Paradimas.
For the chance. My name is Radimas. I am lecturer in electronic engineering education program. Okay. I want to ask, maybe there is a prologue. I have explored one of the largest e-commerce in Indonesia, Shopee, and there is no ready-to-use titanium dioxide, ready-to-use titanium dioxide coating. So, but I just found about powder, titanium dioxide powder. So there is no solution, ready-to-use solution coating. I want to ask, is there a process, maybe a simple process to this powder, so we can apply this solution to our solar panel? So jadi maybe ini bisa menjadi topic research or final project to our student ya. Jadi jika kita bisa membuat sendiri solutionnya berdasarkan powder ini ya, yang ada di pasaran.
Powder itu buat sendiri ke beli ya?
Beli.
Boleh.
Iya, jadi beli powder yang udah jadi gitu ya.
Kalau beli susah nak jadi kecil. Sebab beli dia size mungkin dalam micro, betul tak?
Iya.
Sebab kalau yang kecil lagi mahal.
Lagi mahal ya.
Lagi mahal.
Oh,
So, especially
jadi,
the smaller size. So that's why kalau besar you nak jadikan kecil, you either to use the top down method like Prof ada bincang tadi, guna ball milling, and then you dissolve in some. So maybe you can try using it, but I don't think it's very not practical. Sangat complicated.
So it's impossible if we use this powder ya. Oh, okay.
Powder normally susah nak buat jadi cair.
Okay.
So normally we using the bottom up. We using the precursor, and then we grow the particles from the precursor. It's more easier to controlling the sizes and everything.
Okay, how about liquid titanium dioxide?
Sorry?
Liquid titanium dioxide. I found one in this e-commerce.
Oh, this one. The properties maybe will affected as it compared to pure TiO2. Okay, because this one we need using the light activated and come out with the, because you want to apply on the solar panel, right?
Okay.
Okay. So this one maybe the hydrophilic effect mungkin tak kuat.
Oh.
So you can touch, you can know. That's why, because the properties of TiO2 dia sudah ubah. So that's why you can try and see the solar panel and see. I think you all have the simple instrument, like everything. That's just simple instrument. You can test it and see. You can try and compare with the TiO2 and your liquid. That one, you can do a benchmarking and see. But of course, the solar panel we need transparent. Kalau tak transparent, you will drop. That's why we need to maintain at least 85% above the transparent layer. It's sangat critical. Kalau you exceed the level, sebab sun absorption dia akan kurang. So kurang means your panel tu dia akan tak bagus.
Okay, thank you, Prof. Mungkin last one, Prof. Last question. This is my students, and they are from akhir semester ya. Semesternya akhir semester. Is there mungkin apakah kalau anak-anak ini teman-teman mahasiswa mau lanjut ke master degree di University Malaya, is there any scholarship maybe? Scholarship ada, Prof.
Ada scholarship tapi kena interview. we go through the interview process. Of course, we can be a supervisor and we can give you the recommendation letter. But of course, you need to apply by yourself. Go through our university platform.
Okay.
It depends your interview performance sometimes. And of course, let's say that you have published in Scopus paper, so the chances is very high you can get the scholarship from UM. Because every year we will selected I think 100 students, international students, to join our postgraduate program. Okay, that's why I say that published paper actually can give you a lot of bonus tanpa makan banyak. Kalau you ada Scopus, tapi OS paper, so you senang dapat scholarship. Itulah.
Baik, mungkin itu
because
teman-teman.
you all not only compete with Indonesia but all over the world.
Okay.
So for example, like Indonesia, you can get the government support. It's more better, loh. You can get Indonesia government support. You can because Indonesia actually is the largest foreigner. Go through our campus. China, Indonesia, these are our two largest. Okay.
Okay, thank you, Prof.
Boleh.
Mungkin itu.
Kalau nak further detail mungkin kita boleh share nanti lah. Ada banyak program lagi, mobility program, short attachment, internship, so a lot. Okay.
I think we have also on top of the Prof Lies, the scholarship. I think we have this what we call it bright scholarship. So that is given to the international students for this. Of course, its requirement is quite high, like for example, first class CGPA 3.7 above. Then like Prof Lai say, if you have publication, you have more higher chance. Yeah. For master and PhD degree also have. Only PhD. Okay. Yeah. That's for PhD degree. Yeah. Yes, yeah. Very competitive, I think.
Okay, thank you, Prof. Lei and Prof. Go. Maybe the question and answer are already up, and I want to have a conclusion to our discussion. We have learned that nanotechnology has a very important role in on environmental remediation through nano titanium dioxide and the development of silicon-based nanowires for energy and electronics. Hopefully this session has provided insight and inspiration for all of us. Sebelum kita tutup, izin Prof saya tutup dengan pantun Malaysia lagi. Pergi ke pasar membeli kain, singgah sebentar membeli delima. Terima kasih atas perhatian Tuan dan Puan. Semoga kita berjumpa lagi di masa hadapan. We would like to express our sincere gratitude to our speakers for their outstanding contributions. And with that, I will now hand it back to the Master of Ceremonials to guide the next session.
Moderator Ms. Sarah Najila Hanifati MPD to lead this session. We truly appreciate your enthusiasm and the insightful response from our distinguished speaker. With that, we officially close the Q&A session. Let us now move on to our next agenda. Ladies and gentlemen, we have now come to the end of today's program. On behalf of the organizing committee, we would like to express our sincere gratitude to all distinguished guests, honorable speakers, respected participants, and everyone who has contributed to success of this event. We hope that today's event has provided valuable knowledge, meaningful insights, and fruitful experience for all of us. We sincerely apologize for any shortcomings throughout the event. May what we have learned today bring benefits to our future. May peace be upon us all. Wassalamualaikum warahmatullahi wabarakatuh. Om Santi 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 Om.